firstly, kudos for staying this long. It's been a very long couple of days, and I'm sure your brains are stuffed already. But thank you for sticking with me and for coming along to my session. I know it's like the last one of the day, so thank you guys for being here. So my name, for those of you who haven't gone to my last session or met me before, my name is Grace Jansen, and I'm a developer advocate at IBM, based in sort of Hampshire in the UK. I mostly work with Java, JVM technologies, cloud native, reactive, and all that good stuff. So today, I'm going to take you through a journey of how we can enable our testing to be as true to production as possible. So going through sort of those 12-factor app methodology paradigms where we're looking at trying to get our development, our production, our testing environments as similar as possible, and how we can do that using the magic of containers. So why do we even bother with any of this? Why do we bother writing automated tests in the first place? Well, it's so that we have confidence that our applications work the way we want them to. If we were all perfect developers in a perfect world, we'd just write code, we'd ship it up on a Friday afternoon, we wouldn't get calls at 2 a.m. in the morning for support, we'd have none of that. Instead, we don't live in a perfect world, we do get calls at 2 a.m. in the morning sometimes for support, and we generally don't tend to ship on Fridays for that reason. So really, we write tests so that we can make sure that our applications are behaving in the way in which we expect them to. And there's various different types of testing we can use. You're probably familiar with all of these types of tests. Now, I've created this sort of pyramid to represent the perfect development in terms of the amount of tests and the amount of time and resources we're spending on each of those. So when it comes to unit testing, we're essentially just testing a very small part or unit of code in that example. We tend to write them as we develop the code, especially if you're doing things like TDD, test-driven development. They tend to be quite small, very easy to run. You can run them as a developer locally on your machine. And so we tend to have a lot of them because we need to be testing each aspect of our code, and they are important. Then we work our way up the pyramid, and we get to integration testing. So that's when we're trying to test multiple units working together in collaboration. And integration testing takes a bit more resource, a bit more time, a bit more effort. And so generally, we tend to have less of them. Again, also because we're not testing individual units, we're testing them as a group, so we don't need that many of them. So they come next up the pyramid in a slightly smaller box. And then we have system or UI testing. Some people call it end-to-end, whatever you want to call it. We tend to have less of those, again. Because again, you're using even more time, even more resource, even more energy to be able to do that. And often, if you're doing a complete end-to-end test, you need to be getting everything within your application that you would have in production up and running to be able to test that. Now, this is sort of the ideal ratio of each to each. Again, in my opinion, you might differ. You might have a completely inverted pyramid. But generally, when we actually take a look at our testing, we get a pyramid more like this. So we have lots of time for unit testing because we're developers and we can spend time doing that on our local machines, writing it on our local machines. We spend a bit of time doing integration tests. We can use tools for that, and we have help for that. And then if we have time before we ship, we might do an end-to-end test if we have the time and resources. But we might not always remember, or we might not always have time. But actually, when we're doing testing like this, we end up with problems like this. So this is a sink which has passed all of its unit tests. So yes, the tap turns on. Yes, the tap turns off. The drain works and the sink doesn't overflow. But I can't wash my hands. So it's a pointless sink, right? I can't fill up a water bottle. I can't wash my hands. The water doesn't go into the basin like it was supposed to. It doesn't function as a sink. So actually, as a system, this is pretty rubbish. And actually, if you'd done some integration testing, some end-to-end testing, you'd have realized this sink doesn't work the way we intended it to. So this is the issue when we don't focus enough time and energy on those sort of higher up tests, the integration and the system and UI testing. So this is where containers can come in to help us with this. So what do containers give us that really can help us with the issues we have around creating integration tests? Well, obviously, containers give us all of this magic. So they give us the fact that we can create these isolated development environments. They're really portable, so we can easily move them from environment to environment. We can enable pre-configured images, for example, really fast startup time of our application. We don't need as many prerequisites installed on our local machine. We can have version control, etc. And the two that I'm most interested in, we can develop easily in the cloud. Now, most of our applications are going towards or already at being cloud native, so running natively within the cloud, and true to production testing. Now, this is where the magic really comes in, and this is where we can really utilize containers to make more effective tests. This links back to the dev prod parity. So has everyone seen, hands up, has anyone seen the 12-factor app before? Yeah, quite a few of you. If you haven't, definitely check it out. You can check it out at 12factorapp.net or 12factor.net, I forget. But essentially, it's 12 factors that are listed as sort of behaviors or things to consider when you're trying to create a cloud-native application. Now, one of those, factor 10 in this case, is dev prod parity. Now, there's a sort of extended version of this, which is the 15-factor app methodology, and it's mentioned in that as well, but it's mentioned as environment parity. So no matter whether it's your development, your testing, your QA, your production, whatever, all of your environments should be as similar as possible. And that's what this factor is all about. It's about keeping those environments as similar when it comes to who's utilizing them, when it comes to what tools you're using, what stack you're using. Now, some of the common issues we come across when people don't keep these environments as similar as possible is the time gap, the personnel, and the tools gap. Now, the time gap is, OK, how long does it take you to actually test something on your local environment and then get it into production? That time gap between when you've tested it in development and got it into production means if it's large, there could be version changes, there could be changes in the code that you haven't accounted for. The larger that gap, the more likely that there are errors or failures that you haven't been able to spot because that time gap's crept in. The personnel gap. Maybe you've got a developer testing it locally on their local environment or developing it, and you've got a completely different ops guy actually deploying it, in which case that change in personnel can also mean that errors and failures creep in. The tools gap. It might be that you're using something really fast and lightweight within development because it's really convenient, but then you're actually using something much more robust in production. And again, this gap between the tools that you're utilizing means, again, failures and errors can creep in. So what the 12-factor developer tries to do is really resist the urge for any of these fatalities or sort of issues to creep in and try and keep those environments the same in all of these accounts. And that's to avoid this. Well, it works on my machine. It should work on every machine. You should be able to replicate exactly the error messages that someone else has as well, and your client should have exactly the same experience that you've had testing it locally. So we're trying to avoid this statement or the statement of, well, it doesn't work on my machine. Both of those are bad. You should be able to isolate the errors, find out what's going wrong with your system, and prevent that from going into production. So this is where we can really utilize containers. So if, for example, you need access to databases, for example, you're utilizing things like you want to do integration testing, automatic updating and version control, but can be made much easier when utilizing containers. Any complex setup, so if you have to do loads of prerequisites and really complex setup when you're trying to test locally on your own machine, that can be made a lot easier if you do that all within a container, and that can be then ported between environments. And as I said, portable testing environments. I was ahead of myself. So this is where something like test containers can come in and be really useful. Show of hands, has anyone heard of test containers? Yeah, a few of you guys. Has anyone used test containers? Cool, a few. Yeah, Oleg especially. So for those of you who haven't heard of test containers, it's essentially a framework that enables us to utilize containers to test, hence the name. So it really enables us to write effective integration tests, and it means that you're not just testing your application, you're also able to test anything that it might be depending on. So for example, databases, messaging brokers, etc. There's lots of different modules that are available within test containers, essentially anything that can really run within a container itself that your application might depend on in production. And what it does is it essentially tests your app the same way they would be deployed in production. So it deploys a container, runs your application in that container, and then it deploys anything that you might be depending on in another container to create that sort of almost production-like system that you can then test against. And these are portable to any compatible implementations. Now, there are lots of different implementations you can use, which is sort of the great part about this all being open source. So you can change between vendors if you really want to. You're not locked in at all. So from there, today, I'm going to show you a live demo of how sort of easy this can be when you're taking a normal test that you might be running locally and changing that into one that uses test containers. And to do that, I'm going to be using MicroShed testing. So this is another open source framework, and it uses test containers under the covers. So we're going to sort of be using both today. And it essentially abstracts away even further from test containers to make it even easier for you to utilize this underlying technology and capabilities and the benefits that come with it. So MicroShed testing can be used for sort of Jakarta EE, microprofile, Java EE applications. And it essentially allows for this true to production testing, which is what we're trying to achieve. So it really allows you to, the whole point of this really is to minimize the amount of failures that are creeping into production by making those environments as similar as possible. So how does MicroShed testing work? Well, it utilizes annotations. So it's sort of developed by the same community who develop things like microprofile, Jakarta EE, and all that great stuff. And a lot of those use annotations as well. So actually, all you need in your code is imports, dependencies, and then to add the annotations into your actual classes. The 4 main annotations that you'll need if you're utilizing, oh, yeah, question.
Yeah, is that something replacement for Cucumber?
For Cucumber, so Cucumber is a type of like unit test. So you can use like JUnit testing within this. I need to check, Oleg, is Cucumber supported by test containers? I'd need to check that. I know JUnit is, so it depends on what kind of testing you're utilizing under the covers. But this makes use of JUnit testing.
Cucumber is normally used for integration testing. JUnit is for the
Okay, so yeah. Yeah, so it should be fine. So really it depends on what you're trying to achieve, because you could use something like Arquillian, for example, but Arquillian doesn't allow you to have those supporting components also deployed in containers. So that's the main benefit of test containers, is to be able to have the full system. So all of your backing services, like your databases, your messaging brokers, etc. So that's the main sort of advantage that you gain from utilizing something like this over other maybe more traditional integration testing tools. Yeah, but great question. So yeah, these are the 4 main, yeah, if anyone else has any questions, feel free to raise your hand, otherwise I'll answer them at the end. So these are the 4 main types of annotations. So the first annotation at the top there, at MicroShed test, that essentially is needed so that the build knows that this is a MicroShed test. The at container annotation is required for any setup of the container that you need. So for example, you can see here that we're setting like the context root, for example. You can also set up the sort of, you know, if the container is up and ready, for example. And then we've got the at-rest client annotation. So this is a black box type of testing. So this essentially deploys your application into a container, and it doesn't test from within, it tests from outside to try and make it as realistic as possible for production. So in order to actually sort of implement those tests and actually test your application and use it, you need a REST client to be able to do that, to be able to invoke the methods within your Java classes. So that's why this annotation is needed, to give us something to actually test against. And then the at-test annotation, so just like you were with a JUnit test, this is the same annotation because we're basically using JUnit within this framework. Now, you might be thinking, okay, if I'm running a container for each of my test classes and I've got multiple test classes, that's a lot of containers to be running. And actually, that would be a waste of resources, right? Because many of your test classes might be able to use the same configuration and the same instance of your application, and they might be able to use the same container. So to combat that, they came up with shareable configuration. So this essentially is for any test classes that can share that same container instance, so they can then offload that at container annotation and all of the configuration that you need for that container. So you basically create a separate file that is then, or you could do it in a shared file, which is then that has got all of the configuration you need for the container. And then instead of putting at container in your own classes, you can put the at shared container config, which you'll see at the bottom here, into each of those test classes. So that means that instead of having multiple containers being spun up for each of your test classes, they can just share the same one, save on resources, save on time, etc. So I'm going to take you through a demo now of just how sort of convenient and easy this is to use with a demo application. No, I'm going to go runtimes first. So bear in mind, this is a specification. So if you want to make use of it, you do need to make use of an implementation. So there are various different implementations available. Many of these are open source, and you've probably come across them before. The one that I'll be using in this demo today is OpenLiberty. Has anyone heard of OpenLiberty before? A few. Great. So OpenLiberty is our open source web application server, which essentially allows you to, again, create cloud native applications like many other alternatives might as well. So then again, the nice thing is you're not locked in, lots of different vendors that you can utilize to use this framework. So now the demo. So I'm going to be utilizing, normally I would utilize this. This is the skills network environment. So this is an online sort of sandbox environment that we've created within IBM. And essentially, it's running within IBM Cloud, and it's got all the prerequisites downloaded on it. If you want to have a go yourself, basically getting hands-on with this technology, you can. You can use this online. All you need is a browser. Right now, it's down, unfortunately. Typical for my presentation. So I'm going to be doing it locally. Now, if you prefer to do it locally, that's absolutely fine. We've also got it in the OpenLiberty guides as well, so you can do it locally yourself if that's what you prefer. If you did want to have a go at this yourself, this is the link you need to go to. I can share my slides afterwards if anyone would like that link. Otherwise, picture now. And then, yeah, head over to that. Maybe after today, we're hoping it'll be up. But usual software systems, not always up when you need them to be. So if you go to that link, there are multiple labs. So just make sure you're heading into the lab that's about MicroShed testing. It will say something like testing a Jakarta EE or microprofile application. Should be fairly obvious. Let me just check it. Yeah, cool. So now I will switch into my demo. It does take a little bit of time for me to end the show and that to catch up. So, yeah.
Yeah. Does it have any Jerkins kind of BDD language support for this one? So the BAs and the developers' communication will be easy if something we can written and then it can generate some MicroShed or something like that.
I'm really sorry. I'm a little bit hard of hearing. Would you mind saying that again, but a little bit louder? I'm so sorry. Right.
Jerkins. Do we have support for MicroShed as well?
For microservices?
MicroShed.
Oh, MicroShed testing. In terms of specifically BDD, I'm not sure. I'd have to check on that. Yeah, I'm sorry. Yeah.
Does MicroShed work with Spring Boot?
As far as I'm aware, it doesn't. But I'd have to triple check on that. Does Testcontainers work with Spring Boot?
Yes.
Yeah, so Testcontainers does. I believe MicroShed testing as a framework only works with like Jakarta EE, Java EE type applications, as far as I'm aware. But good question. Sorry, for those online, the question was, does it work with Spring Boot? I forget to read the questions out. Yes.
Test loading. Can we do the test data loading with MicroShed? I think it should be, yeah.
I'm sorry, I don't understand the question.
Test data loading.
Test data loading.
Yeah. So if we want to get the whatever get query or something, then we need to load the data to some.
Oh, to some database?
Yeah.
Yeah, in terms of like, if you want to test access to data to a database, you obviously need to instantiate a container specifically for whatever database you're utilizing, and then write some sort of integration test to check that you're able to access that. That's all possible, absolutely. That's the point of running the separate containers and checking that integration. And that's, as you say, an advantage of using this. It shouldn't hit what, sorry?
It should not hit the live DB.
Live database.
It should not hit the live DB. Our test should not hit the live DB.
It should hit the one that you're instantiating specifically for that test. So it's up to you whether that's, how you set that up, but it will be a test version. Yeah.
Okay. So we do it through the MicroShed, isn't it?
Yeah, you can do it through MicroShed, but you have to set up what containers you're instantiating. So it's up to you to set up, okay, what does my application depend on? Does it depend on a database? What does it depend on? What do I need to instantiate? You can check out the Testcontainers modules, and they list out what databases and external components that you can basically set up. And they have all of the configuration you need in terms of, like, if you're setting up, I don't know, DB2 or something like that, you can set that up in a separate container. Yeah. So as I said, I'm having to do this locally. So what I've done is I've essentially downloaded the same, I can put this down now, the same lab that we would be doing in the cloud-hosted environment. So if you wanted to do it yourself, you would be doing it with the same application. All of our demo apps and labs that we have are usually based around the same applications. We try and make them as simple as possible. This one is slightly different. So if you go in and try any of the other labs, just bear that in mind, that this application is slightly different to the other applications we have in there. So in this one, essentially I've got a single test class right now. It's just a person service it.java class. And I've just got a really simple test, not really testing anything. It's just there for the sake of having a test. So I have the instructions here. So this is the Open Liberty website. All of these can be found within the guide section. If you want to run it locally, this is the page that you need to be on. If you want to run it in cloud, you can select this link, and hopefully it will work for you. You can log in via any sort of social login that you'd like to. So for this one, essentially I've already done the git clone. You'll need to do that yourself. There's a list of prerequisites at the top here that you can see. So if you don't have those already installed, you will need them if you're running this locally. So I'm already into the, so I'm at the moment in the start directory, so I'll just come out. So inside the directory, what you'll find is a finish and a start directory, and essentially the finish is what you should have at the very end of this sort of lab and following all the instructions. So if you get stuck at any point, if you're doing any of our labs, you can always head to the finish and find out where yours differs. And that generally, I find, helps in terms of finding bugs or potential errors that have occurred. Or if you just want to have a go and see what it should be like before you do the lab, you can do that from finish as well. Now, I'm just going to jump straight into start because I'm just going to run through the instructions, essentially, because I know what happens at the end of this guide. So the first thing I'm going to do is I'm going to run it on, so that's if you want to run the finish. I'm going to skip that for just now. So I'm going to run it through Maven Liberty dev mode. So if you've ever used Liberty, you might have come across dev mode before. It stands for development mode. You might have come across like Quarkus, for example, with its hot reload. It's very similar. So it basically allows us to deploy the application, and it means that our application server picks up any changes we make automatically and recompiles those aspects that we've changed when we save a file or a class. So it means you don't have to completely tear down and redeploy your application every time you make changes. So when you're developing and doing small iterative code changes, it can be really useful in checking that your tests still run or your application still runs as it should do. So that's what I'm going to use today. And it does mean that it's pretty quick to see any changes that I make, which is quite useful. So you'll know that it's up and running when you see sort of loads of stars, and then you'll see a message that says the server, there we go, Liberty is running in dev mode. That's the message you want to look out for if you're running this in dev mode yourself. So now that we've got it up and running, what I can do is to run the tests in dev mode, I just hit enter. We didn't want the tests running every time you save and it recompiles, because that would be a pain if you're doing really small changes. So it just runs when you click enter, so it's fairly straightforward and easy. So as you can see, this is just running locally. I've got one test running, and it passed. That's probably because it's not really doing anything. So the next thing I want to do is, OK, how do I now change this very standard JUnit test into a MicroShed test? So this is where those annotations that I talked about come into play. And so that's where is it here? There we go. So now I can add in these container annotations. So again, you can just copy and paste this if you're doing it locally. Just select all and paste. We give you it all. There's little buttons on the ones here if you want to copy and paste them. On the right-hand side, you can use the copy and paste button here, or you can just highlight and copy and then paste it in. And please remember to save. So you can see here that I've added in the MicroShed test, so I'm letting the build know that this is a MicroShed test now and not just a normal JUnit test. I've got the @container annotation in there, and I've got some configuration values for it, so where to find out if that container is up and ready before I actually do my tests, and the context root of it. I'm still using the @test annotation because I'm still using a JUnit test here.
Could you make the font a little larger?
Yes, of course, thank you.
Like your ears.
Is that large enough? Perfect. So now that we've got this in this state, let's have a look and see what happens now. As you can see here, now that I've saved, it's already recompiled for me, so I don't have to do this all again. So I can just hit enter again, and it will automatically run my tests. So now what you see here is it's actually started a container that we're now running this test within. So that's a good start. But what I haven't done is I haven't actually created a method through which I can actually poke my application and test it. So that's where I need the @REST@client annotation as well. So that's the next stage, is to add in that @REST client annotation. So again, you can just highlight, copy and paste, or if you'd rather just copy and paste in the changes, that's totally fine too, your choice. So you can see here, this is where I've now added the at-rest client annotation. So now I should be able to actually reach in and trigger the sort of methods within my Java classes. So now, again, you can see that my tests have recompiled. So if I hit enter, now what we should see is, as well as that container starting up in a minute, yeah, there we see it's building a REST client for me to actually be able to use to be able to test my application. So that's a good start. Now, my test doesn't actually do anything right now, so the next thing for me to do is to actually make it test some part of my application. So what we're going to try and do is create a person. So in this application, I can create people, I can assign them ages, I can search through my database and find out what people are in there, what ages they are, I should be able to update someone. So in this particular case, we're just going to try a very basic, let's see if we can create a person. So again, you can copy and paste, and then you can see here that I've just created something that actually goes within this test to actually test my application. So now we can hit enter again, and we should be able to see that that test runs again within a container using that REST client, and we can see the test has passed successfully, which is great. You might see these sort of warning signs about logger binder. So this is essentially like a logging dependency you can utilize. It's not compulsory, so we're just not using it here. It basically enables you to get more data out of your logs. So if you want to utilize it, you can. We're just not in this demo to make it simple. Question?
Yeah, where's the configure? How does your service know how to communicate with that container?
In terms of how does it know how to instantiate it and like the configuration?
Is this service just running within that container, or is it communicating with the container?
So the service that I'm running is running within the container. So it starts the container and then runs the tests within that container. My application's already up and running. That's why I'm using dev mode.
Got it. And then, but this application is talking with other services, right?
Yep.
And then in terms of the wiring between those services in production, you're going to be pointing at endpoints. And then in testing, what does it look like for how do you get to change how you're pointing to those endpoints so that when you're testing it, it knows to redirect those locally?
So that depends on your configuration. So for example, I've set where the root context is, so I know where to find the particular services that I'm utilizing. It depends on the configuration you've used within your application in terms of, are you externalizing your configuration? Is it within the test classes themselves? Is it within your application? That's dependent on the type of application you're building, what you're trying to connect into. Like if I was connecting into a database, it would be entirely different to Kafka, for example. So it's within the configuration, which is, if you want to take a deeper look into it, it's all open source, so you can head to this GitHub repo, and it will be within the main context. Right now, I'm just editing the test classes, not the application itself. But if you want to take a deeper look at how we're connecting them together, it's all within our main test, our main repository within that, if that makes sense. Yeah. Cool. So now that we created a single test and it's run and it's passed, the next thing we can do is to set up multiple test classes. So again, if you just keep scrolling in this environment, it will show you the new code associated with the instructions. So we can copy and paste this across. And this is now testing several other functions within our application. So we're essentially testing, what happens when I get an unknown person and create, for example, negative ages, et cetera, et cetera. So if I save this again and head on over, hit enter. Oh, I've done something wrong here.
Class has a different name now. You scroll to the top.
That's why. Thank you. Let me undo that. I've scrolled too far. This is what happens in this environment. So testing outside of development mode. Where are we up to? I'm in shared configuration. OK, so normally what would happen is person service ID. There it is. So now I can use all these other tests in this package. Thank you for that. Paste in. So now, for example, I'm testing, can I update someone's age? Can I get all the people within my database, for example? Can I get a single person? Can I get the minimum age? So we're creating a lot more test classes here for us to use. Let's have a look, see if this works. It's still got errors. It still doesn't like me. What is wrong with this? Let's give it another go.
Is there a white space that you're copying?
It might be, still. Did you see at the top?
Yeah, but that
Ah, that's why. Yep, okay. It's gone too far, that's why. My thing isn't working today. So I'm going to leave it with one test. And then let me go to this additional tests and grab these. So in a minute, we will go into shared container configuration, but I've not set up that class, which is why it doesn't like me. Wow. Okay. So that should be the... Yeah. This is not going well today.
you only got assert must null or something imported, but you're doing other assertions now.
Yeah. Which is why it won't work. This one?
No, if you go back to the code at the very top, you've got some imports there.
Yep. There we go. Delete that one. Save. What else have I not got? This. Okay. Now it looks happier. Give it a go. Hey, paired programming with like all of you. Thank you so much. There we go. So now we've got 6 tests running, finally. So you can see that you can just keep adding tests into your test class, depending on how many tests you want to run in each particular test class. That's totally up to you. The next stage is to create the error path IT class. So this is creating a separate class within our container, application, because you're likely going to have more than one test class to run. So this is really to demonstrate that, if you were to run it as is right now with that @container annotation, you're going to be running 2 different containers for each of those tests, for each of those test classes. So if I go in and create the error path IT, error path it.java, delete all of that and paste. Does this have the, great, it's got the shared. It's just not playing ball. Let's try this again. Scroll down. Oh, there it is. That's the one I want. No, shared container config. Okay, it's still got it. So I'm going to leave that right now, and then I'm going to do the next stage. So I've already got the shared container configuration in here. If I was to do it with the @container annotation, then I'd get 2 running in parallel, essentially. So to avoid that, we can create this shared container configuration by adding in another class. So in this case, I'm going to call it the app deployment config.java class. So again, if I add that in, so app deployment, can't spell today. What was the rest of it? Config. Config.java, and paste that in. So now you can see that I've moved this @container annotation into this separate class, which means that I can now utilize this @shared container configuration, and I can get rid of the @container annotation and all that config within the individual test classes. So now I can copy and paste what was there before. Perfect. So now, again, this is the person service IT class. So if we go back into that and replace what's here, we've now replaced it with that @shared container configuration there. So it still doesn't like me. There we go. Thank you, everyone. So now they're all looking OK. I can head back. And essentially what should happen now is that it should only run one single container to be able to run them both within. So now we can run 10 tests within 2 different classes, all utilizing the same container because we're able to share that container configuration for both classes. So we don't have to waste resources and time and energy, et cetera, running multiple containers. So I know stuff went wrong during that, and I apologize for that. Hopefully it'll be smoother if you want to give it a go yourself. Thank you for the help with your pair programming. But hopefully what I've shown you through that demo is that actually, switching from just a normal JUnit test, utilizing the frameworks that are available in the open source community, is fairly straightforward when you can utilize things like the dependencies, the tools, the annotations. So if I now switch back to my presentation, again, this will take a little bit of time just because I'm plugged in. And then we'll go on to the summary and then homework. 'Cause who doesn't love homework? So summary, containers are great. They make developers' lives easier, not just when we're developing, but also when we're testing. They enable all of these magic qualities like portability, flexibility, configuration, the fact that they're really lightweight. They can help us to solve some of the issues that we might have with testing. For example, really enabling us to have that parity between various different environments. And there are some great open source tools available to utilize when you're testing with containers, like MicroShed testing and Testcontainers. And it helps us to speed up time to production, making everyone happy. Win-win. So your homework, if you really are interested, don't feel like you have to do this, but if you are interested in this topic, then I've got some great sort of steps and links that you can go to check out the various different sort of open source tools that I've mentioned throughout this. And if you want to go through our series of how to test your cloud native application, there's a series on IBM Developer as well. I'll give people time just to take a photo. But again, I'll share my slides, so don't feel like you have to. Cool. So with that, thank you very much. Hopefully I've shown you how easy it is to test with containers. Thanks. So we have a question online. Is there any solution to push the images to download within Testcontainer in case the CI/CD is not allowed to connect to pull them in or working offline? So there are some complications when you're trying to use something like MicroShed testing in a CI/CD pipeline. So if you're using Tekton, for example, you're probably already utilizing containers to be able to test within. So it ends up being like a container within a container, and then you can have sort of issues around what the sort of allowances are in terms of security. So are you allowing full security access for that container within the container? What does that mean? So there are some complications around that, which means that you may or may not be able to utilize test containers like this or frameworks like this when you're using a CI/CD pipeline or tools like Tekton. Oh, I'm sorry, your phone's locked. I've lost the question. I don't think my face is going to do it. Thanks. I'm just rereading to check. So I would need to check about, in terms of downloading them, the images, in terms of pulling them in or working offline, because I'm not sure about currently. I know there's some work going on around making that interaction better, so I'd have to double check about that in terms of using it in a CI/CD pipeline. Oleg, do you know any specifics about that? Oleg works for a company that works on test containers, so we have an expert in the room. Do you know anything about that particular topic in terms of?
If you can customize that, they pull images from private registries if
Yeah.
you want, and stuff like that, but whether you can
Yeah, I don't know.
images, have to check.
Yeah.
I imagine that would be possible.
I imagine it should be. I just need to double check. So, Francisco, if you want to reach out to me on Twitter, I will get back to you on that and find out if that's possible. It should be, because you can, as Oleg said, you can specify pulling them from like a private repository. But again, CI/CD gets a bit complicated with this, so I'll have to triple check. Hopefully I've answered your question. Thank you. Any other questions? Yeah, hi.
Does the framework provide any built-in support for like a record and replay mode? So that you can run the tests, and then once you know what the requests and responses are, being able to run them more efficiently with record and replay? Or does it not have any support for that out of the box?
That is a good question. I actually haven't ever tried to do that. I don't know. I want to say probably not right now. I think it's mostly just the annotations that I showed. I don't know whether there's like another tool that you could use in collaboration which would allow for that. That's a good question.
The other thing about using another tool in collaboration is that then if you were to run in a replay mode, you'd want to not spin up the containers. So is there a way to have those annotations on there, but then for some test cases, or for some ways of running the tests, specify not to
Turn them on and off, basically. Again, I don't know that there is a way to do that. I'm trying to think whether. Yeah, I don't think there is, as far as I'm aware. but that's a good question. The question, sorry, for online people, the first question was, can you essentially do sort of like a test and then record, so you can basically watch back what happened within the test to know? And the second question was, can you utilize it in collaboration with other tools? So can you turn the annotations on and off? I don't think you can, but I'd have to double check that. But it's a good question, because you might not want to have it all the time. I get that. Yeah, I'd have to check. Yeah.
Can we spin multiple instances and test with that actually? We're using MicroShed, just spin the multiple instances of the applicant services, and can we go ahead with the testing? Trying to understand how the MicroShed works.
Yeah, so in terms of, you can spin up as many of the test containers as you need. So for example, if I have an application where in a particular integration test, I'm testing my connection with a particular database, and then in another integration test, I want to check, oh, well, this particular part of my application is using maybe Kafka, for example. I want to check that. You can spin up different containers, and that might be where you can't use shareable configuration. So you might need to use your own @container annotation with config within that particular test class, or maybe you use a separate shared container configuration for multiple test classes. That's up to you, but you can spin up as many as you need, but just be wary that obviously you're utilizing resource when you do it. It really depends on what your integration test is trying to test, and what backing services you need running in various different components, or when you're running it. Yeah, because obviously this isn't a system end-to-end test. You're not testing everything at once. So this is for integration tests, so testing a smaller part, but obviously multiple units all at once. Yeah. Hiya.
Thank you. There was a point about prod parity, and that's where I'm a bit lost, since it seemed as if it's comparable to prod. I mean, that's the point that was made. But then if we are just integration testing, and the way we're communicating between services is not the same, then how can we talk about prod parity and being comparable to how it is in prod?
Yeah.
Like, to the point that the gentleman here was making, that if the communication is different, and if the exam points are just mimicked, then how can it be comparable?
So it shouldn't be different to what you're running in production. Like, it should be the same application, so it should have the same. Sorry, I forget to talk to the online people sometimes. The question was about the dev prod parity and whether this really does mimic production when, for example, there might be differences within the application when you're running using this kind of framework. Would you say that's fair? So I would say that, the application that you're testing it against, you shouldn't be changing it between running an integration test like this and running a full system end-to-end test. Like, the actual application should be the same. It's just the test classes that are different, right? You're creating integration tests within your test classes. I could run it as a single unit test if I wanted to and create a separate class for that. But the actual application and how those services communicate should be the same, because that should be set up within your application code. In terms of, is it production? The answer is no, it's not meant to be exactly production, because you'd be running a system or end-to-end test. This isn't meant to replace that. This is just meant to be the layer above a unit test, enabling a more parity than just running it on your local machine, for example. So it's a step in the right direction. I would say it's not meant to mimic your entire production system, because at that point you use an end-to-end or a system test, because that's the point of them. We still need all those different types of testing, but this is to make integration testing as close to production as possible by mimicking it using those container environments, because it's going into a container. And so, as you say, the way it communicates with those different services is going to change if you were just to run it locally. So that's the idea behind it, if that makes sense. So it's getting closer, or as close as we can get with an integration test, I would say.
The CI/CD kind of widely practiced, is that still common that somebody runs tests locally?
As in my experience, yes, but maybe that's just my experience of the enterprise world. I can't comment for everyone, but from my experience, yeah. Oleg, I don't know if you've had any other experience with companies running tests like locally versus CI/CD.
Well, you run both, right? And you externalize the setup. Your external dependencies cloud stacks, you can run them in test containers as well with stuff like projects like LocalStack, for example, that kind of mimics AWS setups. Your own third-party services that you consume from your code, you don't want actually to spin them up, because that will mean that you have to enable and deploy the whole fleet of microservices, right? So you want to mock them, but you want to mock them as external dependencies that you actually consume the same way as you would consume like third-party API. So you like wire mock them and provide the contract what they need to respond to you. So you draw a line at the dependencies around one individual service that you test. And then you test them the same way in locally, right? You run your application and you test them the same way in your CI pipeline, where, yeah, just with a larger environment rather than running an individual unit test.
That's what I mean. There would be contract testing involved if you were to rely on that as a consumer. And the producer would provide the contract that you could then check out at every run. But we can probably take this offline.
Yeah, sounds like a more in-depth discussion. No, good questions. Thank you. Any other questions? Nope. Cool. Well, thank you very much for listening.